I was reading a linear algebra book that came out not too long ago, and the authors came up with something called the rat poison principle. And I want to explain what it is. It's something that they made up in this book by Mex and Mex called linear. The book is just called Linear Algebra. What's the rat poison principle? The rat poison principle is this. Let's say that you have something and you want to know if it's rat poison. How do you tell if it's rat poison? You feed it to a rat. If it dies, it's rat poison. That's what they call the rat poison principle. So it's kind of silly, but it actually makes a good point. The point they're trying to make is, if you want to know whether something is a certain thing, you have to ask yourself, does it satisfy the requirements that make something that thing? So for instance, if rat poison is defined to be anything that kills a rat, then if you want to know if something is rat poison, okay, then you have to feed it to a rat and see what happens. In other words, what makes something rat poison is how it's defined. It's defined by what it does. If you feed it to a rat and it doesn't die, then it doesn't count as rat poison. And so how is this relevant to linear algebra or math in general? Let's say that you wanted to know, is 2, 3 a solution to the system 3x minus 2y equals 7, x plus 4y equals 9. Well, what's the technical term that we have? Solution. The question is 2, 3 a solution? Now, what does the word solution mean? What makes something a solution? It's a solution if, when you substitute 2 and 3 into the equations, you get a true statement. That's what makes something a solution. So what should we do? We should plug in 2 and 3 into these equations and see if they are true. So if you plug it into the first equation, you get 3 times 2 minus 2 times 3. Is that equal to 7? Question mark? Well, 3 times 2 minus 2 times 3 is 0. And 0 is not 7. So what's the answer to the question? No, right? The answer to the question is no. And it sounds very simple, but actually a lot of questions in math that students have trouble with, once you figure out what the question's even asking, a lot of the difficulty just goes away. And notice that we had to know what makes something a solution, right? We had to know the technical meaning of the term solution. This is a mathematical term, and it has a technical definition. It's not used, the word solution is not used in the ordinary language in everyday English, right? And if you had something like, this was just one example, but there are lots of examples like this. So for instance, an eigenvector, as we'll see, is a non-zero vector V, such an eigenvector of a matrix A, such that it is a non-zero vector V such that A times V is lambda V for some scalar V. Some scalar lambda. So let's say that our matrix is 1, 2, 3, 4, and our vector V is 0, 1. So is V an eigenvector of the matrix A? Again, this is something where we apply the definition. We have this question, is V an eigenvector of A? What word do we need to understand the meaning of before we can answer this question? We need to know what an eigenvector is. Okay? The word eigenvector is a technical term and it has a technical meaning. And when you read the definition of eigenvector, it says it's a non-zero vector v such that A times v is lambda v for some scalar lambda. That's what makes something an eigenvector. So if you have this matrix A and you have some vector v and you're asked, is v an eigenvector, what is the question saying in plain English? In plain English, it's saying, is A times v equal to lambda v for some scalar lambda? That's a way to phrase the question without using the word eigenvector. So what do? We find what A times v is, and then we ask, is that lambda times v for some scalar lambda? So what we should do is we should calculate A times v. A times v is this matrix times this vector, and when you calculate it, you get 2, 4. Now, is 2, 4 equal to lambda v for some scalar lambda? So that's v, that's A times v. Is this a scalar multiple of that? Well, no, right? This is not of the form lambda times 0, 1. So it's not equal to lambda 0, 1 for any scalar lambda. So the answer to the question, is v an eigenvector of A? What's the answer? The answer is no. And here's the reason. So keep this in mind when you have questions like, is something, right? The general pattern is some object that you're given a, something. And we have to ask ourselves, well, what qualifies an object to be that particular thing? So some questions that you might see in a linear algebra class is, is the set linearly independent? That's a question you might be asked. Or is the set a basis for some subspace? Right? We need to know what linearly independent set means. We need to know what a basis means. If the question is, is the matrix invertible? We have to know what it means for a matrix to be invertible. What qualifies a matrix to be invertible, right? What distinguishes a matrix that's invertible from a matrix that's not invertible? So those are the questions that you would need to ask yourself when you have these kinds of questions. So if you're given, or another example is such and such a subspace? They give you a set, and then the question is the set a subspace? So we need to know what counts as a subspace. Or is this function a linear transformation? Right? Or an eigenvector, or whatever technical term. The point is that these are all technical terms. They're not used in the sense of just ordinary, everyday English, right? They have precise technical meanings, and so you should memorize these. you should memorize exactly what these words mean. Memorize the definitions. Okay? In calculus, you might be asked something like, is the function continuous at x equals 3, or something like that, right? And then what's the technical term? Of course, it's continuous at a point. And continuous at x equals 3 means that the limit as x goes to 3 of f of x is equal to f of 3. So to decide whether f is continuous at x equals 3, you need to figure out what that is, and you need to ask yourself if they're equal. If they're equal, then f is continuous at x equals 3. If they're not equal, then f is not continuous at x equals 3. So this might be something that you're not used to doing in previous math classes, and this is one of the things that I think a lot of students struggle with. I mean, it seemed kind of obvious that, of course, if you want to know if something is insert whatever technical term you have, of course you need to know what makes something count as one of those objects, right? But a lot of students, if they're asked, is 0, 1 an eigenvector of A, one thing that a lot of students do is they'll try to calculate the eigenspace, and they'll find the characteristic polynomial and do all of this, and you don't need to do any of that once you understand what the question's even asking, right? The question is V an eigenvector of A is just saying, if you do A times V, do you get a vector of the form lambda times V? Similarly, if you have something like this, is 2, 3 a solution to the system, you don't actually have to solve the system, right? It's just saying when you plug in 2 and 3 into your equations, do they come true? That's all the question's asking. So otherwise, you could be spending, if this system were really complicated, right, you could be spending forever finding the general solution to the system. You don't have to do any of that. In differential equations, this shows up. Is, y equals x cubed a solution to some differential equation? They're not asking you to solve the differential equation. That's not what the question's asking. The question's asking, if you plug in y equals x cubed into your differential equation, do you get a true statement? That's all it's saying. So one of the skills that hopefully you'll get used to is asking yourself, what exactly is the question asking, right? What's the definition? Remembering that technical terms are not used in the sense of everyday English. They have technical meanings, and to be able to answer questions like this, you have to know what the words mean. And that's something that you might not be used to doing in other classes, but the sooner you get used to it, the easier linear algebra will be. And if you ask anyone who's qualified to teach linear algebra, right, what's an eigenvector? What's a basis? They should be able to tell you they will, if they're, qualified to teach linear algebra, they will be able to tell you a basis for a subspace is a set of vectors that's linearly independent and spans the space. They will tell you the technical definition of an eigenvector, technical definition of a linear transformation, technical definition of invertible matrix, diagonalizable, all these things. They have these things memorized. So you should memorize them too. Okay, and that's what Mex and Mex were trying to explain when they made up this rat poison principle. So I hope that helps you learn linear algebra. Thanks.